Now we are going to see how a memory, a RAM, indeed could be connected to our Datapath. You can see it already shown here. A RAM or memory could be connected to our Datapath by connecting the A data line into the address input of the RAM, then the B data line into the data input of the RAM, and then adding some new control signal which is called as MW or memory write. Okay, when memory write is equal to 0, it means that we are not going to write into it, and when memory write is equal to 1, it means that we are going to write into the memory. With the A data, we determine which address in the memory we are going to write, and the B data provides the actual data that we want to write into the memory. So obviously, in order to write into the RAM, we must give an address and a data value using A data and B data respectively. So the A data is connected to memory's address input, B data is connected to memory's data input, and by setting MW equal to 1, we will be able to write into the memory. If we want to read from the memory, the value that we have on B data will not be important. We need to provide proper address through A data, and then we need to set memory write into 0. So indeed for reading, the memory write should be equal to 0, while for writing, memory write should be equal to 1. Maybe you need to update this as well. So memory write equal to 1 means that we are going to write. Memory write equal to 0 means that we are going to read. And when we want to read from the memory, the data that we have on B data will not be important. We just provide proper values through A data, which will be the address to which we refer. We set MW equal to 0, and then we will have the data at the output of the RAM provided. And then you can see that the output of the RAM is connected to the one inputs of the M multiplexer. Okay, so here we have the multiplexer which selects whether the output of the ALU should be connected to the D data or whether the signal that we receive from the RAM will be selected and connected here. So if you want to read from the memory and use it in our ALU, we need to set MD equal to 1. If MD is equal to 1, then the path for the data will be like this. This is what we have for MD equal to 1. If MD is equal to MD equal to 0 means that we will have this path for the data. So the result of the operation that we had in ALU will be passed into our register file. Something to notice here is that the ALU or the function unit doesn't have direct access to the RAM. If we want to perform any operation on the data which is stored in the RAM, first we need to read it, store it in one register in our register file, and then perform the operation in the function unit. So now with this setup, we have a way to copy data between our register file and the RAM. We can write into any memory element that we have in there, and we can read from it by providing the proper address and proper data when we want to write. And as I already mentioned, there's no way that for the ALU to directly access the memory. The ALU will perform operation on the data which may come from the memory, but the data will go through the register file, and then they will be available for function unit. And the result of the operation that we get from the function unit could not be also written directly into the memory. We don't have this option. It needs to pass again through the register file, and then it could be written into the memory. And one more thing here is that the size of the memory that we use here and we can attach to our system is limited by the size of the registers. In terms of the number of the elements for our RAM, it is limited by the size of the registers which we have here, n number of the bits for the address. Therefore, in total, we can have up to 2 to the power of n memory elements or words, memory words. And the width for the words is also determined by the number of the bits that we have on the B data over here, which is also equal to n. 2 to the power of n memory words of n bits. So the RAM that we could have here will be in the form of 2 to the power of n by n in terms of the size. For now, we assume that the RAM is at least as fast as the CPU clock. So we can perform the operation of reading from the RAM or writing into the RAM in a clock bus, but this might not be the case in real processors these days because the processors will be much faster than the memories. When we want to do the transfer of the data into the memory or reading the data from the memory, we use a special notation. Over here you can see the notation that we have, memory in brackets x, where x is the address. The first word in the RAM is denoted by m in brackets 0. Okay, so this is the first word inside the RAM that we can address. And then we can use registers in order to determine a specific address within the memory. Memory m in brackets r1 means that we are referring to the address in the memory, which is determined by r1 register. So whatever content we have for r1 will determine the address in the memory.